Well, thank you everybody for joining me here today. My name is Ryan Milligan and I am AEF Deputy Team Leader for Communications and Marketing. My focus is on the North American communications, but happy to be here today in Europe and giving this presentation. I also am Director of Powell Electronics. Our booth is right there, the agricultural products that my company makes and distributes. Today we'll be talking about high-speed data communication on industrial machinery. But really the bigger picture in this story is that a data standard can drive interoperability for an industry, so the different manufacturers' equipment can work together, but it can also really promote innovation in that industry to make the industry grow and increase the customer experience and benefit everyone. We'll be covering some of these topics today. We'll get a brief history of the electronic standards in the ag industry. We'll talk about a concept called ISO bus, or an internationally standardized CAN bus. We will discuss the next generation they're calling high-speed ISO bus, as well as the objectives of high-speed ISO bus, what that architecture is going to look like, and how that has caused an industry collaboration to come together around a certain technology that's going to promote a joint working group ISO standard to be in draft. We'll talk about where that work is specifically, where those drafts are, as well as some of the concepts that the AEF is handling, the Agricultural Industry Electronics Foundation is handling, protocol tunneling or CAN tunneling, as well as really driving the digital camera systems work for these new ISO standards. And then finally, we'll do a brief review of the high-speed ISO bus components and availability as suppliers are now coming together to support this technology. Really, the story starts way back in the 90s when an internationally standardized CAN bus system was developed for ag vehicles to talk between the tractor and the implement. This was ISO standard 11783. And in the early 2000s, it wasn't really widely accepted. But in 2001, the AEF, the founding members of the AEF started to realize there needed to be another guideline on top of this standard to bring together an ISO bus concept. Because in the mid-2000s, their equipment manufacturers had all interpreted this standard differently, and you had a mishmash of connectors, kind of like at the top of the slide there, where each of these manufacturers had interpreted it differently, and so the connectivity was all different, the data protocols were all different, and it was quite honestly a mess for the consumer. The keywords here are ISO bus, and there was another need for some sort of conformance test on top of the international standard to allow interoperability to happen. We really wanted to give the customer an experience that is similar to this architecture, where a tractor of a certain manufacturer could tow implements of different manufacturers and have the proper information come into the tractor's internal monitor. So they wanted to have this interoperability. Specifically in Europe, mixed fleets of vehicles on the farms were very common. And that's now even becoming the case in the United States, as certain regions want special equipment. They have certain crops they're growing, so they want specialized equipment that doesn't necessarily match with the brand of tractor they have. Much like your commercial electronics has a standardized universal bus as a USB port, they needed something like that for the ag equipment. So to give the customers that experience, the AEF was founded in 2008 by 7 global ag equipment manufacturers, shown here. And today there's 8 major equipment manufacturers, but a total of over 300 members of the AEF. There's a worldwide support of this ISO bus concept, so it's been widely accepted, it's been successful. And there's 11 different project teams within the AEF that drive certain precision agricultural functionalities. So the different use cases and application layers of this system are driven by 11 different teams of experts and engineers pulled from all of this membership. So that the subject matter experts are pulled in from all the top companies. And really, that was the genesis of the AEF. It was a need for a round table to make ISOBUS successful, to make this 11783 standard a really globally accepted and successful standardization. There was, they needed to standardize on ISOBUS. They needed to integrate it into the vehicles. Everyone needed to integrate it the same way. And they wanted to really increase the user experience. That was the focus of it, is we want our customers to be satisfied and have an ease of use, a plug and play. So the first job of the ISOBUS was to reduce cab clutter. There was many different implements towed behind tractors, and you quite literally had an experience for the operator of the tractor where they had trouble seeing out of the cab. There was so many different displays required, so many different auxiliary controls. We needed one universal terminal, one universal interface for the person operating that tractor. We wanted to take this, quite literally, this is what one of the cabs would look like, and the vision was to bring it to this kind of experience. I've got one terminal, one joystick, and I can operate all of the different implements. My sprayer, my seeder, my hay baler, all works with my tractor on these controls. So to support that concept, AEF has several different products that they have available to their members. They do have a certification process that uses a conformance test. There's also a database which is free to everybody, so consumers can use that to say, I have a tractor that does this, and I want to match it up with a baler that does the same thing. You can use this free database to make those kind of compatibility checks. All of this the work is moved forward through a series of plug fests, which happen twice a year. And plug fests are unique because you have competing companies coming to the same engineering tables to check their electronics against one another. So you have tractor folks who are the engineers in charge of the tractor sitting there with their representation of their electronic controls, and the implement guys move from table to table and plug in and make sure the displays are getting what everyone expects them to get. Also, the AEF publishes guidelines, so new companies can say, I want to use ISOBUS, how do I implement it, how do I make sure I'm compatible? And so these guidelines are available to member companies as well. All of this can be certified through 5 global test labs where you can take your equipment and go to these test labs and certify them as ISOBUS. So at the time of introduction, there was really only one functionality, which was that universal terminal concept. But as our member companies came together, they started to realize that there was a lot of different precision ag functionalities that we could agree on and we could move forward. And so this is why the AEF was introducing this concept of we have more functionalities that we want to standardize on using this system. Some of those include things like Task Controller Basic, which Task Controller Basic is basic job data. How much am I spraying? How much am I yielding? What am I doing while I'm in the field? And combined with Task Controller Geo, or the GPS data, the farmers started to get really good information of what they're doing, what happens as the results of these actions, and year over year, when you compare that, you can make even more informed decisions about how you're going about the work on your farm and the results that you're getting. So you're dialing in these efficiencies. It became a real return on investment for the farmers to go for this higher level of precision ag machinery. Task Controller Section Control is another thing that really helped the farmers see a return on investment. They use GPS data to, if you're driving a sprayer and you overlap at a certain spot, you're not going to duplicate the application of that into the field. Seeders, the same thing. And by doing that, you're cutting down on waste, but there's also a sustainability aspect to that too, where you're not completely putting too much into the soil that then ends up in the water, and this is a more sustainable practice for the farmers to use now. So what's next? Well, electronic standards succeed because the global acting players accept, align, and enforce these standards. And this has been proven by ISOBUS. So how are we going to build on the success of this ISOBUS. It's been widely accepted, all the companies are doing great with it, and it's a customer benefit. Well, the ag and tech, heavy vehicle tech is ramping up quickly, and we needed really a technology that had higher data speeds. CAN bus is 250 kilobits per second, and relative to the technology available now, that's quite slow. So we needed to get 1 gigabit of data for precision command and control. And this is also really focused on now bringing cameras into this system. How do we combine the available digital video aspects into our interoperability concept? So the decision was made by the AEF. A team called High Speed ISOBUS was formed, and they decided on a technology based around 1000 base T1 type B. And what that is that's a 1-pair Ethernet. You know, common Ethernet is 12 wires or 8 wires. This is a single pair of wires that is able to do a gigabit of data up to 40 meters. What wasn't available on the market when the AEF started this product team was they didn't have high-speed ISOBUS connectors, they didn't have a defined channel for communication, media-dependent interfaces, or physical interfaces. But again, the farmers just want it to work. So as long as they can plug and play with their equipment and they don't have to do any configuration and IT work, they're happy. So the advantages of choosing this single pair Ethernet or 1000 base T1 type B was that it's a very flexible and scalable model. It has type B specifically has that 40-meter cable reach that's needed to go from a tractor cascading down multiple implements. It's small and lightweight. It's one pair of wires, so the connectors are smaller, the cables are smaller. It's much more efficient for weight. And then there's a lower power cycle. So wake and sleep can be defined with a lot less power. In fact, there's already been a study done that says since you don't have to start the vehicle to turn these systems on, 17% less carbon emissions by having this new system on there, because the CAN bus system required you start the tractors. There's the required security and safety that needed, and this single pair Ethernet technology will work in the ambient temperatures of negative 40 C to 125 C. As well as it can be supported by a comprehensive package of standard software protocols. Really, 1000 base T1 type A, it enabled connected and autonomous cars. 1000 base T1 type B is going to enable connected and autonomous tractors and heavy vehicles. The objectives of this new high-speed system were going to be a higher bandwidth, a lower latency, and a 4,000 time improvement over CAN bus. This will result in higher level of command and control, the ability to remote view cameras, as well as a system that updates hundreds of set points in 10 microseconds. They also want to, again, focus on the user experience and make sure it's an improved operator or user experience. The CAN bus standard has been around now for over 20 years, so they wanted to also have a long lifespan for this and not only make it backwards compatible, but future-proof for use cases that we haven't even thought of yet. It's environmentally rugged to the temperature and humidity, as I mentioned, so the connectors have ingress protection. There's an EMI, EMC shielding across the whole backbone of this system, and the vibration is handled through a more rugged or large connector contact using 20 wire gauge, which is not standard on automobiles. It's 20 wire gauge and larger is standard on these heavy vehicles. The AEF needed to define the tractor hitch, in-cabin, rear hitch connectors, as well as how do you cascade these implements up to 40 meters. Really, the higher level of command and control that we were talking about can be seen on the John Deere See & Spray sprayer, where you have a machine in the field that instead of spraying the whole field, it's using a camera to identify a weed or a bug problem and just spray that one spot. So it goes from section control, where they're turning off sections of the vehicle that overlap with work they've already done, to I can shoot one specific plant with what it needs. Additional objectives are the system architecture needs a backbone and connectors, as I mentioned, but it needs to allow for also private or proprietary solutions. These machinery companies want to differentiate their product from one another, so it needs to have the ability to expand to their proprietary solutions as well. But that then communications need to be used across this backbone so that it follows protocols where the implement and the tractor can understand one another. So really the anticipated future with this higher bandwidth is a wireless in-field communication that will include machine-to-machine communication, machine-to-cloud, as well as use cases that are remote camera viewing, bulk data transfer, and the example of that would be shared prescription maps. Two machines in the field working on the same job can know what the other one's doing, where the other one's covered, and that's also a use case for construction equipment, earth-moving equipment, where you can all use the same prescribed map to the work that needs to be done and work in tandem without duplicating any effort. For the ag industry, this is what the architecture is going to look like. You have a tractor control interface and implement control interfaces that cascade up to 40 meters. You can see here the ISO 11783 system is still on 2 of these vehicles. So you have CAN bus that can be brought into the Ethernet backbone. So when the third implement does not have CAN bus on it, you can get that data down to the third implement. And you have aftermarket devices that may be different camera arrays or different spraying aspect that can do that. But off backbone, there are cameras, there are antennas for wireless in-field communication, and these aftermarket devices possible. So there was lots of challenges and opportunities to doing this. Really, the opportunities were that we're going to leverage the supplier expertise of the components, and we're going to leverage the industry experts from the equipment manufacturers to tackle these issues. They're going to help us standardize the industrial connectors and cables that we need. They're going to write these standards, and that there was more 1000 base T1 test suites being developed by the software and testing companies. So that's being filled through these companies coming together on a standard. And also we needed the semiconductor companies to buy in. When you have one application on a tractor only needing 8,000 pieces, the chip manufacturers don't want to hear that. They want millions. So we needed to bring a lot of the industries together to make the silicone and semiconductor suppliers interested. So the high-speed isobus technology and architecture come together because of industry collaboration. We needed to leverage all of the open alliance standards that the automotive industry has used, but we needed to bring multiple industries together to get the type B, which is specified for 40 meters. So a collaboration has started between similar needs industry groups. So the large equipment manufacturers can all aggregate on the same type of microchip, and the PHY suppliers, the chipset suppliers, know that they've got a viable market to supply into. This also brings in their subject matter experts from the chip manufacturers. And so the development of a common standard was not only feasible, but it was needed. So this came together starting in 2020, where there was an informal collaboration between a couple industry groups working in the ISO standards. But it migrated in 2022 into a specific work group, which is Technical Committee 127, Joint Working Group 16. And there was an invitation-only kind of environment where they brought in similar needs industries technical committees. So you had earth moving, ag electronics, mining equipment, on-road truck and trailer, forestry, and construction equipment all coming together to start on this standard. As well as the AEF, the organization that I represent, they were fully immersed in this joint working group. Many of the ag equipment manufacturers also make construction equipment, so it kind of made sense to bridge the gap. And that's what joint working group looks like now. It's got a piece of all those different technical committees across the European and American standards. It's co-convened by the earth-moving machinery and the ag electronics groups. So the benefits of the industry collaboration can really be shown here when you talk about what do we need that's industry unique, what do we have in common, displayed across the OSI 7-layer model. you can see all of these different aspects as you move from the physical layer to the application layer using this OSI 7 layer model. All of this can be common to multiple industries. We feel that only the top level application and the bottom physical layer is really where you're going to have differences in the industry's requirements. So that made this really efficient as far as the joint working group goes, because you can assign specific industries specific topics. And here's an example of where the status is of that work. Our AEF has created their guidelines 41, 42, and 43, and because they're part of Joint Working Group 16, those are already now documents in this new standard. Also, the AEF has continued work on CAN tunneling and the basic protocol as well as middleware. And there's other groups that haven't quite been formed up yet, but these ISO documents are in draft currently. An example of how they used previous standards to inform the current standards is the CAN bus or the ISOBus standard was used, and they just removed the physical layer. And then they add a query, what speed is your interface? And based upon that answer, so the query and response behavior can allow the CAN bus signals can be transmitted over the Ethernet. What that does is shown here in a model where there's an example of a planter with 50 rows and 5 different parameters per row. So one refresh of those parameters could be 500 different data transactions. When you're talking about using CAN to do that, you're talking about something that takes almost half a second. But when you'd use Ethernet to do that, it's microseconds to update hundreds of data points. So 14 full parameter refreshes using Ethernet can happen with 0.01 bandwidth of this system in microseconds. Single pair Ethernet is also very scalable. So the legacy systems had different physical layer independent systems that all required different software stacks interfacing throughout the vehicle. When you employ single pair Ethernet, you move towards one single physical layer that covers multiple different data speeds and thus multiple different systems, all using the same software stacks. So it takes away a system that had 5 different softwares, 5 different connectors, 5 different wires, and makes it all work with one wire and one set of connectors. The digital camera systems from AEF have taken over another ISO standard that will be used in the new one. Basically, it's a highly active team within the ag industry. So they're the ones now developing the camera system requirements. And ISO 17215 is really working to develop cameras that are fully plug and play. The idea of this plug and play is that you can combine aftermarket devices, different cameras for different applications, and drop them into your tractor with no configuration requirements. You can combine the OEM systems with an aftermarket system. And all of that should be completely seamless for the farmers to decide, make the decisions about their machinery about that without having to know how to configure the network. Also, by updating this standard, the AEF is offering stationary camera applications another standard that's plug and play. So there is no plug and play camera standard right now. This is being updated for ag and heavy vehicle, but it's completely anticipated that stationary camera applications like factory automation and other industries will be using this as well. An example of the difference in the architecture would show here that the agricultural industry, construction industry, they need one data channel. But when you talk about on-road truck and trailer use cases, they're going to require 2 data channels. So that's going to be a different connector system. But they need it because they incorporate the vehicle braking into this autonomous action that's needed. So they're requiring one dedicated channel for braking and safety. Summary of the work is that the AEF high-speed ISOBus has focused on the ag requirements, and they focus on plug-and-play interoperability between manufacturers. They're working on the CAN tunneling, and these AEF guidelines are used by ISO for 23870 documents and ported right in from AEF. The digital camera team is focusing on plug and play, no configuration required camera systems. And they're also making a guideline that's going to go directly into ISO 17215. The CAN protocol is being finished as well, so you can be backwards compatible to the old machinery. And there's a diagnostic aspect to this work that's also just started. Really, when you look at the list of the documents that are being drafted in the ISO, you look at 4 of them that are really required for the higher command and control of these vehicles, and these are what is being worked on first. And I will just go through some of the connectors that are available and some of the hardware available for this system now. This is based upon the AG requirements or the AEF guidelines. I'll cover a couple silicone suppliers that are working on these chips and some other components. Really, when we talk about 1000 base T1 physical layer, we needed 1 pair Ethernet based upon the Open Alliance Automotive Ethernet, but it had to be 40 meters, and it also needs to have a variety of different connectors, opportunity to do multi-gig communications, a media-dependent interface for the switch, and different physical interfaces for the chips. Power could be 12 or 24 volt based upon the industry, but a non-destructive breakaway is really key. If you have a hitch, there's an opportunity that the hitch and the implement and the tractor may not be connected properly or at all, and then the tractor pulls away and would damage all the electronics if there was no non-destructive breakaway. So you have a connector system that pops apart under a certain force and doesn't destroy the electronic harnessing. And as we reference the physical layer, we're going to see a system that now does have quite a few connectors involved in it. When you consider the J1939 CAN bus for diagnostics, the ISO bus connector for the back of the tractor, and all of the different cameras that are being used, as well as RJ45 and some automotive. Really, to be backwards compatible, all these connectors are going to exist on the vehicles for about the next 20 years. But eventually, because we wanted to be future-proof with high-speed ISO bus, all of this CAN bus activity will migrate to one connector set, and these are the only connectors that are going to be needed on the vehicles. A company called Rosenberger in Germany won the high-speed ISO bus breakaway connector request, and really they had a connector that was meeting all of these off-road requirements, and it had the ability to do 24 and 48 volt operation over 15 amps power pins. It's a shielded 1 pair of data, and it has 6 connector coatings, each industry kind of grabbing a connector coating for themselves, so you don't have any confusion if you try to mix equipment for some reason. TE Connectivity has taken their DT, or the Deutsche Transportation line, and updated it with single pair Ethernet inserts. So this connector system is part of my product, the Ethernet switch, in that it allows for 1000 base T1 Type B, but it's using the Open Alliance TC9 Class 2 shielded interface and available at 20 wire gauge, which is important for the heavy vehicles. Some other products that are available are listed from these companies here: Harding, Powell, Vector, B+. There's a lot of bigger companies here that are focusing on these Ethernet switches now. Really, as far as Powell Electronics goes, we're focusing on being a stocking distributor for all the different connectors. We're a TE distributor, we're a Rosenberger distributor, we're a Harding distributor. We also understand the assembly process and have the tooling to assemble single pair Ethernet cables. So we're happy to work on prototype cables and can then move to production with companies if needed as well, with high volume partners. We also have, through a partnership with a specific equipment manufacturer, we have a 1000 base T1 and TX Ethernet switch. And this switch accomplishes a lot of what the architecture needs. You can bring in the CAN bus into it, the standardized Ethernet, or 1000 base T1 1000 base TX, but it also has a port for Type B that can go to 40 meters. And that's a first of the kind in the market, commercially ready Ethernet switch that has 1000 base T1 to Type B for 40 meters. Harding also makes Ethernet switches, but right now they only make switches that have Type A. Their focus is camera systems and factory automation. So they are working with the M8 and M12 connector form factor, and that doesn't quite meet the ruggedness requirements of these heavy vehicles. but it still could be used for certain aftermarket devices for ag equipment. Vector makes adapters from CAN to 1000 or 100 base T1. So Vector is a company that you could use as a media converter to take your CAN bus to an Ethernet signal. B Plus also makes Simulio products that will go between 100 and 1000 base T1, supporting 100, 1000 base TX. They are currently updating their product to Type B, and they'll be supporting this market. The silicone suppliers are, it's a hit list of all the big names. I know that commercially and out in the market, Ethernovia, Marvell, and Texas Instruments all have ready-to-go chips for 1000 base T1 Type B. If you're interested in the work that the AEF's doing, maybe becoming a member or looking into some of their products and certifications, I have here their contact information. And I'm right here at this booth, so if you'd like to talk about any of that connectivity, any of the products that we mentioned, Powell Electronics booth is right across the aisle here. So thank you very much for your time today, and I appreciate it.